Hello students. Today we'll start the third experiment, and the aim of this experiment is study and practice of connection and reverse the direction of rotation of a three-phase induction motor. So we will discuss how to reverse the direction of rotation of a three-phase induction motor and its connection also. So the apparatus required for these experiments are a three-phase induction motor whose specification is three-phase 415 volt 50 cycles per second having 9.5 ampere running at a speed of 925 rpm. We will also require connecting probes of 2.5 square copper wire with spanner of specification 16 by 17. We will also require a wire cutter which is insulated one having 15 centimeter of length. Quantity required is 1. Now we will discuss the theory. So before understanding the theory of three phase induction motor, we have to understand the theory of a single phase induction motor. As we already know that these single phase induction motors are not self started. For making them self-starting, the use of one winding by the help of the starting winding, the single phase induction motor are self-started. So in other words, we have to convert this single phase machine into multi-phase machines. So by introducing an additional starting winding, we can achieve it. By creating necessary phase shift, we can produce two phases. So the starting winding and running winding are somewhat identical. By connecting an external two-way switch, the starting winding and running winding can be interchanged and the direction of current flow is reversed. The change in current direction changes the induced field direction, in turn reverses the motor armature direction. Now we'll discuss about the three-phase induction motor, which is the aim of this experiment. I have made you understand about single-phase induction motor because without understanding the principle of rotation of a single-phase induction motor in their reverse direction, we cannot understand how to reverse the direction of rotation of a three-phase induction motor. Now, three phase induction motor has self starting torque. The rotation of the torque or rotor depends on rotating flux which rotates at synchronous speed. If the phase sequence of supply voltage is given to the motor is changed, the direction of rotation of flux also changes, which in turn changes the direction of rotation of motor in order to change the phase sequence of the input supply. Only two supply terminals connected to the stator are to be interchanged. So students, mind you that since we are having a three phase induction motor which is operated obviously by a three phase supply, so if it is rotating in any direction after supplying the three phase supply, we have to note it down. Then when we intend to change its direction, we have to interchange any two phases only. We cannot interchange all the phases. We have to interchange any of the two phases. That means if it has been connected as R, Y, and B, then we have to change the sequence. Either R should be connected to Y and Y should be connected to R and B as it is. Similarly, not only with R and Y you can interchange with Y and B. Also, you can interchange from B and R. So it depends upon the operator to interchange. After interchanging the phases, you can easily reverse the direction of rotation of a three phase induction motor. Now let us understand the reason why the rotor of an induction motor is set to rotation. Why it is important? Because already we know that single phase induction motors are not self-starting, whereas three phase induction motor are self-starting. They do not have any modification so as to make them start. So let us understand. So when a three-phase stator windings are fed by a three-phase supply, which is very much obvious also, because it is a three-phase machine, we have to fed it by three-phase supply only. A magnetic flux of constant magnitude but rotating at synchronous speed is set up. So students, when we fed three-phase supply, there will be a magnetic flux, because we know wherever there is current associated in any circuit, there is flux linked with it also. So if it is a single phase supply, then there will be a flux corresponding to this single phase supply. If there is a three phase supply corresponding to this three phase supply, there will be a flux associated with this current. Now the flux passes through the air gap, sweeps past the rotor surface and cuts the rotor conductor, which as yet are stationary. So we are talking about the instant when the three phase supply has been fed. So at that instant only this rotor is at stationary. So now what happens after few instants, due to relative speed between the rotating flux and the stationary conductor, an EMF is induced. An EMF is induced in the same as the supply frequency. Its magnitude is proportional to the now uh, the stationary conductors, and EMF is induced in the latter according to Faraday's laws of electromagnetic induction. The frequency of the induced is the same as the frequency of supply. Its magnitude is proportional to the relative velocity between the flux and the conductor windings of the induction electric motor, and its direction is given by Fleming's right hand rule. Since the rotor bars or conductors form a closed circuit, rotor current is produced. So if there is a closed path, then there will be a current produced in it, and whose direction will be given by Lenz's law. And it is in such a direction that, or the direction of current will be such that it will oppose the very cause which produces it. In this case, the cause is which produces the rotor current is the relative velocity between the rotating flux and the stationary rotor conductors. Hence, to reduce the relative speed, the rotor starts running in the same direction as that of the flux and tries to catch up the rotating flux. And mind you, students, this chasing is continued throughout the motor operation. It never succeeds in catching the rotating flux. So can you tell me if what will happen if it will reach or it will catch up the rotating flux? Obviously the motor will come to rest, because there will be no relative speed between the rotating flux of the stator and the stationary rotor conductors. So as a result, the motor will be brought to rest. So this thing never happens. So that is the reason why a three-phase induction motor rotates, and it rotates in your the direction of the rotating flux. Now you have the circuit diagram. As you can see, the phase sequence in the first circuit is interchanged in the second one. Earlier we were having RYB, in the next one we are having, now here in this diagram we are having YRB. So by interchanging any of the two phases of supply, we can change the direction of the rotation. Now the procedure part, it has to be written in past form. I have written the hints, you have to elaborate them. So first the motor has to be connected as per the given circuit diagram. The circuit is given in your upcoming video. You can also refer to the circuit just above this procedure. Start the motor. The motor was started and the direction of rotation was monitored. Now we have to keep a record that where we have taken the reference of rotation. If it is from the back side of the motor, we have to also write from the back side of the motor the direction of rotation was observed to be so and so. If it is clockwise, then clockwise, then if it is anti-clockwise, then it is anti-clockwise. Now switch off. Now switch off the motor. Interchange any two phases as I have already stated in your theory part. Now again we have started the motor and we have monitored its direction and found to be rotating just in the reverse direction. You have to draw the conclusion and answer the review questions. How the direction of rotation of a three-phase induction motor can be reversed. What do you mean by synchronous speed? What is plugging? What will happen if all the phases are interchanged? Explain why three-phase induction motor are self-starting. So this concludes your experiment. You have to keep a record and you have to write these things in your lab record book, and it will be followed by a next video which in which you will be having the circuit diagram, and we will also run this motor. So watch the video and get the relevant datas, and I hope that you have understood from this experiment. So thank you for watching, students.